Welcome to Saurav Sir's classes. Today in this session, I'll be basically looking at the JAM 2020 paper in physics, and basically we'll be solving the problems one by one. So this is the way I'm actually going to proceed with the problem solving. First, I'll read out the problem, followed by I'll basically give the reasoning as to how we can solve the problem, and then I'll be basically mentioning the options that are given and will point out the right option. Alright, so let us begin. Let's look at the first problem. So these are all multiple choice questions, which means there are 4 options given, out of which one will be a correct option. And there is another category of questions called multiple selection questions, in which there are 4 options and more than one might be correct. We'll be coming to those questions later. We'll first begin with the multiple choice questions. So let us start with the first problem. Which one of the following functions has a discontinuity in the second derivative at x equals 0, where x is a real variable? So x is a real variable, and the function, there are 4 functions that are given in the 4 options. Fx equals mod of x cubed, fx equals x times mod x, fx equals cos of mod x, fx equals mod of x squared. So these are the 4 functions that have been given in the options, and we are asked to evaluate which of these functions will have a discontinuity in the second derivative at x equals to 0. Now we don't actually have to go through calculating the first derivative and second derivative of this function. In most of the cases we can actually arrive at the answer with an educated guess, and this is exactly what we're going to do here. So let's look at the first function. Fx equals mod of x cubed. So what does this mean? This basically means mod of x cubed is equals to x cubed when x is greater than 0, minus x cubed when x is less than 0, which again means x cubed for x greater than 0, minus x cubed for x less than 0. So if we plot this function, actually see that this function, it may appear smooth here, but actually it will have a kink. It actually has a kink here. So if I zoom it, this is how the function looks. This is a zoomed version of this function, which means that this function has a discontinuity in the first derivative itself, and therefore its second derivative will actually blow up. It will go to infinity. So this is not our option. Let's look at the second function, or rather let's look at the third option and the fourth option, because those are very easy to guess. If you look at it, fx equals to cos x, it is cos of x for x greater than 0, cos of minus x for x less than 0. But cos of minus x is cos x by symmetry, which means it's a smooth function and it has no discontinuity in any of its derivatives. So we can rule this out, and we have also ruled out number 1. By the way, this should not be confused with x. This is just a cross mark that I'm using for ruling out the options. And finally, if we look at mod of x squared, it is also basically for x greater than 0 and Again, it's x squared for x less than 0. Smooth function, and hence has no discontinuity in any of its derivatives. Ruled out. So now we know that our only correct option can be x of mod x. And if we just write it down, it will be x squared for x greater than 0 minus x squared for x less than 0. And the plot basically looks like this. This is the plot of x mod x. And from here we can see, but now if we take the first derivative, the function, from here we can see that the function is smooth, but if we take the first derivative, it gives me what? Twice of x for x greater than 0 minus twice of x for x less than 0, which we can write it as twice of mod x. And we know that mod x itself has a discontinuity at x. Mod x is discontinuous. Not discontinuous. Mod x has a discontinuity in its first derivative at x equals to 0, which means this function will have a discontinuity in its second derivative at x equals to 0. So our correct option is x times mod x, and the answer is option B. See, all we basically did was make an educated guess based on the function's nature. We didn't have to do a lot of derivatives, and this is exactly what you need to do during the exam. You cannot be wasting time on one problem. You need to basically make educated guesses and try to arrive, or try to at least single out the right option as quickly as possible. Let's look at question number 2. So question number 2 says, a collimated beam of laser light of wavelength 540 nanometer is normally incident on a smooth glass slab placed in air. Let us draw it. This is a smooth glass slab, and the laser light is incident normally on it. Given the refractive indices of glass and air are 1.47 and 1.0 respectively, what is the percentage of the light reflected back? That's what they're asking. So we are given the two refractive indices. N1 is basically N of air, which is 1.0. N2 is N of glass, 1.47. And this refractive index, mind you, is for 540 nanometer. We don't need to use the information of the wavelength directly, as we'll see very shortly. We just need the refractive indices. So all we have to calculate is the reflectivity, and then multiply it by 100 to come at the percentage of reflected light. And the reflectivity has a very simple formula. When you have normal incidence, there is no dependence on theta. All you have is N2 minus N1 by N1 plus N2 whole squared. N2, so it's basically 1.47 minus 1 by 1.47 plus 1 whole squared, and that gives you about 0.47 by 2.47 whole square. Now, if you have trouble calculating this in your head, there is a very simple trick that I'll show you. Just imagine the nearest number which you can divide easily. So first, let us get rid of the decimals. Decimals can cause undue confusion, at least it does to me. So I'll write it as 47 over 247, and we can approximate it by 50 over 250 whole square, which is about 1 over 5 whole squared, 1 over 25, this is about 0.4, and that would translate to 4%, but this is less than, 47 is less than 50, and 247 is less than 250. So, although there is an option of 4%, we should still keep in mind that the actual numbers are 47 and 247, and that will probably come out to be slightly less. They will come out to be slightly less the actual number that came out is about 0.036, or which is about 3.6%. So the correct option is actually option C, which is our reflected light percentage. Okay, so this problem is done and dusted. Let's proceed to the next problem. Problem number 3. Two stationary point particles with equal and opposite charges are at some fixed distance from each other. 2 point charges are basically at fixed distance from each other. The points having zero electric potential lie on. Let's draw 2 charges. Let's call this plus Q, let's call this minus Q. And these are point charges, mind you. And let's say the distance is d. So they are asking me to find out what is the locus of the zero potential line. Now from here you can see that if I take a plane at the mid distance d by 2, we'll basically see that this plane, everywhere on this plane the potential is 0. Everywhere on this plane the potential will be 0. You just look at this point where the plane intersects the line, join the 2 charges, the potential is 0, and likewise the potential is 0 everywhere on this plane. So we don't even need to calculate anything, and we can see that the equipotential line in this case is a plane due to the symmetry. This is our equipotential surface, or zero potential surface. But the answer is B. So you see that there's nothing to solve here at all. All you had to know was how to employ the symmetry of the problem, and the answer just reveals itself. And this is exactly what you have to try in all the entrance exams that you appear for. Remember that the exams are all time bound, and you cannot afford to lose a lot of time just trying to solve one problem. If you cannot solve a problem, move on to the next one. Let us move on to the next problem. Problem number 4. For a system undergoing a first order phase transition at temperature Tc, which of the following graphs best describes the variation of entropy S as a function of temperature T? So we are asked to evaluate, PT stands for phase transition. We have to basically evaluate which one is a possible Ts curve for it. So I'll draw all the 4 curves for you. So these are the 4 options that are given, the 4 curves, T and S. T is on the x-axis, S is on the y-axis. The first curve is like this. It's Tc. Second curve is like this. It just changes its concave convexity after a certain point, and there is a critical temperature Tc corresponding to the phase transition. The third curve has a singularity at the Tc. It has a singularity at Tc. And the fourth curve has a discontinuity at Tc. Now, which one of these is a possible phase transition curve for a first order phase transition? Now we'll argue it step by step. So if you remember the definition of phase transition, it says that for a first order phase transition, the first order derivative of the Gibbs enthalpy function will be discontinuous. So the order of phase transition is given by the order of the derivative of the Gibbs enthalpy, which is discontinuous. So Gibbs enthalpy as the derivative of Gibbs enthalpy as a function of temperature is what we need to look at. Now, how does it relate to S? Very simple. All you need to remember is S is the negative of the derivative of the Gibbs enthalpy as a function of temperature. It is actually at constant pressure. And this is all we need to know. How? Because if we now take the derivative of entropy as a function of T, take the derivative of entropy with respect to T, we basically get this. So for first order phase transition, if del G del T is discontinuous, del 2G del T2 has to blow up. It blows up. And we see that there is one option where del S del T, the derivative, has actually blown up at the critical temperature. And so this is our desired first order phase transition. The answer is option C. So you see that how we actually figured out things just simply by recalling the definition of phase transition and a relation which relates entropy to the derivative of Gibbs function with respect to temperature. So the correct option was answer C, in which the entropy blew up at the critical temperature. Question number 5. Let's move on to the next question. In photoelectric effect experiment, a monochromatic light source emitting photons with energy hello